There's a few useful properties of sigma notation which will make calculating with sigma notation a little bit easier. So we'll just have a quick look at what some of those properties are. First of all, we need to be sure that we understand what this symbol means, which is the sum from k equals 1 to n of ak. And all ak means is that it's some term, which is a, involving k. And we've got k down here, so we know that we're starting with k equals 1. So this would be the sort of thing, you know, where you would have 2k minus 4. So you let k equal 1, you let k equal 2, you let k equal 3, and so on. In its most basic form, however, all this means is we work out what the first term is when k equals 1, whatever that is, we write it down. We work out what the second term is when k equals 2, and so on. We work out what the third term is, all the way through to our end point, which in this case is what n equals n. So we need to rely on that little piece of information before we go any further. So the first property that we're going to have a look at is the sum from k equals 1 to n of ak plus bk. So what this means is we've got two terms involving k. So an example of this might be 4k plus 1 plus 3k minus 2. So these are each terms involving k, and we're adding them together. So if we just expand that out and see what it looks like, it's going to be a1 plus b1, so we let k equal 1 for both a and b, plus a2 plus b2, plus a3 plus b3, plus all the way through to an plus bn. What we can do then, because it's all addition, it's commutative, which means we can do it in any order that we like. So let's just pull all of the a terms out first. So it's going to be a1 plus a2 plus a3 plus all the way through to an plus, and then we'll put all the b terms, b1 plus b2 plus b3 all the way through to bn. And you should see that this a1 plus a2 plus a3 all the way through to an is actually equal to this. So we can make the substitution that all of these a terms are in actual fact the sum from k equals 1 to n of ak. Similarly, and I'll do this in orange, similarly these b terms are the sum from k equals 1 to k equals n of b of k. And so the property that we've discovered here is that the sum of ak plus bk is the sum of ak plus the sum of bk. Okay, that's our first property. The second property that we're going to have a look at is what to do when we've got a factor. So if we've got the sum from k equals 1 to n of ck. Now what this means is ak is just any term involving k, and c is a constant multiplying that term. First of all, we spell it out term by term. So it's going to be a1. C is not affected by any value of k, so it just stays there as a factor, plus ca2, plus ca3, all the way through to can. You should notice that every term has a common factor of c, so what we can do is pull that out the front as a common factor, and we're left with a1 plus a2 plus a3 plus all the way through to an. And then we recognize that this is just our very, very general term, c times the sum of from k1 to n of ak. So what we've shown here is that when we've got a factor multiplying our term, we can in fact pull that out the front and let it sit out the front as a common factor. All right, the third one that we're having a look at is what to do when we're talking about the sum from k equals 1 to n of a constant. So this time we don't have a term that k influences. Does it mean the whole thing collapses and it doesn't exist? It actually doesn't. What it means is we let k equal 1, and when k equals 1, our expression equals c. I'll just pop k equals 1 under there so we can be sure. When k equals 2, our expression still equals c. When k equals 3, our expression still equals c. All the way through to when k equals our last term, n, it still equals c. So then the question becomes, well, how many of these do we have? And you can see we've got 1, 2, 3, 4, 5, 6, who knows how many in between here, but we know that our last term is our nth term, so we've in actual fact got n lots of c. So when we are adding the sum from k equals 1 to n of a constant, c is a constant, then our result is simply our constant multiplied by our number of terms. There are some questions in the chapter where you'll need to rely on those properties, so you might need to come back and have another look at them. All right, that's it.